Okay. This next reaction that we're going to go through involves the creation of something called imines, or imines. However you want to pronounce it, what it is a carbon-nitrogen double bond. And these are fairly useful in synthesis, but before we can get to that, let's talk about the reaction mechanism of how we make them. In general, your main way of making imines is to take a carbon-oxygen double bond and react that with an amine. So for example, NH3. Now I'm going to first summarize what you should expect, and then we'll talk about the actual mechanism of it. What you can expect is basically if you redraw the C double bond O that you started with, and then just erase that oxygen and put your nitrogen there. Now, we want that nitrogen to be neutral at the end of the reaction, so I need to have the proper number of hydrogens. A nitrogen is neutral when it has 3 bonds, so I should have 1 hydrogen on it. In general, the imine formation will cause you to lose 2 hydrogens in the process of whatever is over the arrow. Okay? So this is what I should expect, going from a ketone to an imine using an amine over the arrow. And sometimes there will be some H+ floating around to help things happen. Regardless, let's go through the mechanism now. How does this actually happen? Okay, so we said let's do slightly different. Let's do NH2CH3. So I'm going to have a methyl on this one, but we should still be able to predict what we should get. We know that at the end of this reaction, all I have to do is replace the oxygen of the double bond with the nitrogen and have 2 fewer hydrogens on that, so NCH3. This is what I should expect to get. Now, how does this happen? Well, just like anything else, a carbonyl, or just like any other reaction involving a carbonyl, we know the carbonyl likes to move up and resonate with its carbon, right? And so you can get O- carbon positive. What might want to attack that carbon positive? The lone pairs of your nitrogen. Okay? So now I will have, after my first step, 2 carbons that were originally there. We have the O- that forms when this double bond swings up, and then you have the nitrogen that did the attack, with everything that was on it still attached, so the 2 hydrogens and the methyl. Okay? Now, based on what we're supposed to get, we need to make that oxygen leave somehow. And generally, when you want oxygen to leave, you need to protonate it, make it H2O positive, a good leaving group. Well, we have O-, we have this nitrogen over here, which will be positive because it has 4 bonds. That oxygen will go and do a proton transfer, neutralize the nitrogen, and now you are left with OH, nitrogen, methyl, and then 1 hydrogen. 1 hydrogen got removed, the other remained. Okay, and then we have the 2 methyls that were originally there. Now our goal is to make that oxygen leave, and like I said, to do that we need to make it H2O positive. So do that arrow a second time. Have this oxygen grab the other hydrogen of your nitrogen and move those electrons down onto the nitrogen. So now we went from something that's neutral that grabbed the proton, so that oxygen gave up a lone pair. It's going to now become H2O positive, a good leaving group. And on that very same carbon, you have a nitrogen that is now negative because it got the hydrogen's bond electrons. So you have NCH3 minus, and then the 2 methyls that were there originally. Now our goal is to kick out the H2O and form a carbon-nitrogen double bond, and the way that happens is the nitrogen's lone pair will swing down and form the double bond, kicking the H2O out. And so you will finally end up with what we expected. The 2 carbons that were originally there are still there. The nitrogen formed a double bond with N, and it had a CH3, and now it is neutral because it used its lone pair, gave up electrons to make this double bond, plus water, the H2O that got kicked out. Okay, so that's the general gist of the formation of an imine. And now we also have a way to reverse this. Let me erase these arrows. One thing that I've been stressing a lot throughout the semester is the fact that every mechanism you learn, if it's reversible, pretty much every intermediate you have will be the same intermediate going forward or backwards. The arrows and what's over the arrows might change, but the intermediates will always be the same. And it turns out we can turn an imine back into a C double bond O by treating it with water. So if you're given an imine and you have water over the arrow, what you should expect is just erase the nitrogen and whatever is attached to the nitrogen and put an O there. So for example, in this, here's my double bond NCH3, erase the nitrogen and whatever is attached to it and just put an O there, which is what we started with. Now, let's go through the actual arrows of this mechanism. Well, just like C double bond O, the electrons of a C double bond N react mostly the same way. The electrons want to go up to that nitrogen through resonance because nitrogen is more electronegative. It likes being negative. And that would make this carbon positive, making it fairly attractive to the water molecule. And would you look at that? If the water attacks there and the electrons swing up to the nitrogen, you get H2O positive and N minus. Okay? Now, we're going to do a proton transfer to neutralize these charges, so let me draw out my hydrogens. That nitrogen will grab one proton and the electrons swing over to the oxygen. Now we have OH neutral and H neutral. Now, since we're going backwards, our goal is to make the nitrogen leave in this case. So if we wanted in the going forward to make the water leave, we protonated it and made it positive. If we want the nitrogen to leave, we protonate that and make it positive. So have that nitrogen grab a proton from the oxygen, swing that over to the oxygen. Now we have NH2 positive with its methyl, and O minus. And in the same way, going forward here, to make the water leave, we kicked it out with the formation of a double bond. Do the same here. Oxygen forms its double bond and kicks the amine out. And now we're back at the carbonyl. So going forward with imines, you start with a C double bond O and react it with some nitrogen with however many carbons or nitrogens. And if you want to break apart your imine going forward, you react it with water, or H3O positive. The only difference between water and H3O positive is H3O positive is a much stronger acid, so it would likely start the reaction by protonating the nitrogen. But that would be the only key difference, the matter of a single proton. Otherwise, it's mostly the same.